So I go about explaining a character device, first starting with our modules, our included modules. So the first one, that's module.h, which is included in all kernel modules. The next is the miscellaneous device.h, which is included in all character devices. fs.h is something which contains our file operations struct. So now why do we need this file operation structure? Now if we see here, which is defining what character devices are, it's a device that communicates by sending and receiving a single character. So for the sending and receiving from various buffers, we need our input output, and that's present in the fs.h. Functions such as read and write from buffer are present in the fs.h. Next we have poll.h, which includes all the POSIX functions, which is used for multiplexing input outputs. Now what does one mean by multiplexing input outputs? That is, multiple inputs and output channels at the same time. Next we include the error number.h module, which contains all the error numbers which can be accessed using a macro such as einval. And we also have our init modules, which is used for macros such as initialization and exit functions, which is present in almost all kernel modules. So next, let me start explaining this module, this character device, from the initialization function. So first, here we are trying to register a device. Now every device driver have a major number and a minor number, and by doing this miscellaneous register for the address of my device driver structure, which is present here, we first see that it contains a miscellaneous dynamic minor. Now what this macro does is it initializes a dynamic micro to our miscellaneous device. Now what about the major? Major is fixed for all the miscellaneous devices. Major is always 10 for any miscellaneous device, and we get the minor number using this. The next line consists of our module name. Once we insert this module, we'll be able to see this as a character device in /dev folder. And my FOPS is the file operations structure, which is obviously characteristic of the miscellaneous device. So that's what this first line is. So let's move on to the FOPS, that's a file operation structure. Here we see the owner name, which is just in case if I go to the place where this is. Here we first see that it's structure module and asks for the owner. So by saying .owner, we are mentioning the owner of this module. Yeah, next we see the .read and the .write, and those are the functions that's going to be so these are the functions that we'll be writing above, and it's going to be passed into the file operation struct. So let's first look into the myRead function. This myRead function has a set of values, and all these values are provided by the file operation struct. But let's just go over them. So here __user is standing for the user space. So whenever we have something that is part of user space, we use the __user macro. Next we have count. Count stands for the maximum bytes this function has to read from, and this ppos stands for the position of current position in the buffer. So here we first see that we get our initial buffer, and we give it the value, which is a predefined value with the word ran. So what this myRead is doing is it's going to be reading it from this buffer. That is, it's going to be reading from this is called our initial buffer, and it's going to be pushing it to the user space buffer. So here we see return simple read from buffer count ppos initial buffer and length. Now how do I know where it's pushing from what? We can go to this function, which is simple read from buffer, and if we read the documentation here, we first see to user space buffer to read to. And next we have so we pass in our initial buffer as a second last variable, And the second last variable is from, and if you go to from, the buffer to read from, and our first variable is a buffer to read to, and that first argument is buffer. So we're going to be reading to the user buffer, which is received from our file operations struct, and it's reading from the initial buffer. So this function pushes it from the initial buffer to the user space buffer. Next we have the my write. Like my read, we also have a bunch of arguments which is given to it from the file operations struct. And what this does is it's going to be pushing the value from the user space buffer to say input. So we are creating this value over here because we're going to be comparing the input we get from the user and the value that we have already predefined right here. And we also create a character type array. Why a character type array? In C, all the strings are just an array of characters. Here we also take care of length to make sure that the length of the input and the length that we have pre-mentioned here is the same. Also we have, even though the string's length is 2, we have mentioned the length is 3 because there is a terminating null character in the end of 43. So it's 44, 3 and a null character, so that makes its length 3. Yeah, so we first see if the count, that is the thing to read from the user space buffer, is equal to the length that we have mentioned here. If so, if it's not, then we can just return our error. I have actually typed it wrong here. And right now we are reading it from the buffer, which is the user space buffer right here, to the input. That is, we are receiving a string in terms of an array of characters. And just like the previous function, ppos is the current position in the buffer is a user space buffer, and count is the number of bytes this function must read from. And it's possible that writing the simple write to buffer is has given an error. So we check if the value of readval is below 0. A value below 0 shows an error, so we just return it directly. Else, if else we compare the string to the predefined string that we have and the input we got for count amount of bytes. If it's equal, then pass in count, else pass in the error value. So I guess we can and as per every module, we also have an exit module where we are deregistering the miscellaneous device, and we have these two functions for telling where the initialization and the exit functions are. So I guess we can now go ahead and try and make this clean. And let me open one more terminal for super user. And sudo insmod star.ko, and here if you change to do ls, let's actually do that here, /dev. And here we can see our module that we have just inserted, game. Now in order to run this, I can do cat /dev/game, and here we get our value 43. Now what about the comparing thing? Like now when we just did this, we were just calling this function right here, the myRead function. We did not do anything with the write function. So in order to do something with the write function, let's pass in the value to our char device. And in case if I pass in some gibberish or a really long number, it'll say it's an invalid argument. But if I pass in the same value that we have there, it'll actually let me input this value into the char device, which shows that this string compare is actually successful. So this clearly shows that we can get an input and output through with the help of simple read from buffer and simple write to buffer in a character device. And with that, I'll be ending this explanation on CAD devices. Thank you.